Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MEL3E, grade 11 workplace math, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 9 till 10 in the morning, and we are in our 4th week of our 9-week course. At this point, you definitely should be considering to submit some of your work for marking, even just the beginning. So a reminder that the support questions, the ones with the little pencil icon, are not for marking. You can decide which ones and how many to do. If you're understanding a concept, it is totally okay to skip some questions and do only what you need to confirm that you're feeling comfortable with that concept. But also, if you need more practice, totally ask for more practice, and I'm happy to provide it for you. The key questions are the marked questions. So these ones you need to do all of. You need to show all your work, your steps, and your thinking. This way I know what it is that you know, and if you are struggling with something, then I can help you out because I have more information. So how do you submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. So you can scan your completed work using a device. If you have an Apple device, the Notes app has a scan function, and if you have an Android device, the Google Drive app has a scan function. They're fairly straightforward, but if you need some support, on my YouTube channel, there are tech tutorials that walk you through how to do each step for both of these 2 different apps. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand in your work to your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1432. Sorry, 737-1732. My bad. I don't know where the 4 came from. Or toll-free fax to 1-800-463-7852. Students can also fax in their work. If you are interested in doing that, if you have access to a fax machine, just give us a heads up that you're sending a fax, because sometimes things get lost in the shuffle. If you'd like to connect with me through social media, you can connect with me through Facebook or YouTube. Both of them are under the name B. Slate Wahsa. All of our radio Zoom classes are recorded, and I upload them to YouTube shortly after broadcasting. So it's a really easy way to access all of our information so that you can really get everything you need. Also, there are short videos explaining common errors and confusing concepts on my channel, so that is a good place to check out if you are struggling with something. Then there might be a video that is just like 3 minutes or 5 minutes that addresses that topic instead of having to do a general online search. Math is a really visual subject, so I strongly encourage you to access the videos. Either join me live through Zoom. Whether or not you talk to me, you don't have to, that's totally fine. Or watching the YouTube replays, both are great options. If neither of those work for you, you don't have reliable internet or something like that, then let me know and I'm happy to send you a copy of the videos so you still get the full experience. So if you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is B. Slate Wahsa. You can call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., but I teach from 9 until 11, and so that is not a great time to try to get a hold of me. today's lesson is lesson 9, compound interest. So our learning goals are that at the end of this lesson, you'll understand the benefits of compound interest for investment and the drawbacks for loans. And you'll be able to explain what principal, interest rate, time period, and compounding are in various situations. You know that you've met these learning goals because you can explain how compound interest earns more for investments, but costs more for loans. And you can identify the principal, interest rate, compounding periods, and time in order to find the final amount. When will you use this in real life? We are identifying the information we have and what we need to find. So with this lesson particularly, it's a word problem and we need to pick out the information, and it might be what we're expecting that we need to find, or we might not be, but being able to figure out what we know and what we don't know is really useful. And that is something that is transferable across life in terms of many times you need to figure out what you do know and what you don't know. So it is a really good, important skill to develop. First, let's do some brain activation and with some mental math. I don't believe in mad math minutes. They cause stress and anxiety in more students than not. And so this is not really a useful way to spend our time or really setting students up for success. So instead, in our courses, we develop strategies that we can use in various situations that are based on our level of comfort and friendly numbers for each of us individually. So today's question is 2016 divided by 168, and this is a proportional reasoning question. So definitely with this kind of question, my gut instinct is to reach for a calculator, which is totally a legitimate solution. But if doing this by long division, if you don't have access to technology for some reason, and having to do this through long division, just feels daunting. So what we're going to do instead is we're going to use proportional reasoning. So we're going to divide both of these numbers by the same number in order to separate and cut things down but we're still talking about the same things in proportion. So let's see what I mean by that. So 2016, well, I'm going to divide that in two. I can see that it's an even number, so I can cut that in half. And so that's 1008. So if I cut all my things that I'm dividing in half, I need to also cut my groups in half because I want to have the same proportion, but now I'm just talking about less stuff. So 168, well, I know that 160, half of that is 80, and half of 8 is 4. So that's going to be 84. And I can still see that I still have two even numbers. So the friendliest thing for me is to just continue to cut this in half. You can do it. You could cut in a different amount, like that's fine. You don't have to use half, but dividing it by 2 is friendly for me. So that's what I'm going to do. So 1008, cutting that in half is going to be 504. And 84 cut in half is going to be 80 cut in half is 40. So 4 cut in half is 2. So 42. And again, I still have two even numbers. So I'm going to do it again. So if by chance you could see at the beginning that these numbers were divisible by 8 and you wanted to cut them both by 8, that's fine, but you don't have to. So 504 divided by 2 is 252. And 42 divided by 2 is 21. Okay, so now 21 is not an even number, so I can't divide it by 2. So that stops me. But I know that 21 is divisible. Like 3 times 7 is 21. So I can look to see if 252 is divisible by either 3 or 7. 7 is a tricky number, but 3, I know that if I add up my digits, if they add up to a multiple of 3, then that whole number is divisible by 3. So 2 plus 5 plus 2 is 9, which is divisible by 3. So that means that 252 is also divisible by 3. So I can divide both of these by 3 to continue to get my numbers to be friendly. So 21 divided by 3 is 7. 252 divided by 3 is going to be a little bit trickier. I need to think about that a little bit more. So let's see. Well, I know that 3 times 60 is going to be 180. So it's going to be bigger than that. 3 times 80 is going to be 240. So that's getting closer. So I just need another 12 to get to 252. So that means 3 times 4 is 12. So 3 times 84 is equal to 252. So 252 divided by 3 is 84. And then 84, so now 7 is a prime number, so I can only divide it by 7. It's dividing it by 1 is not going to be helpful. So that means I have to do 84 divided by 7 as well. So again, I can think of, well, I know that 7 times 10 is 70. And I know, oh, that I need 14 more. So 7 times 12 is going to be 84. So 12 divided by 1 is equal to 12. So this whole thing, 2016 divided by 168 is equal to 12. Now, obviously, this is not totally simple. There was a few steps that we needed to do, some that we need to do a little extra thinking on, but it made more logical sense to me than doing long division and separating the digits and having no idea what I was dealing with. So not necessarily a tool that you're going to use every single time, but it can be a really useful tool sometimes. All right, so what prior learning do we need to know? Let's turn our minds on. I just want to remind you what compound interest means. Remember, we did in our previous lesson, lesson 8, we connected simple interest to compound interest. So we could see how they were related. So a reminder that compound interest is earned on both the principal of your investment and also any interest that you've earned. So it has exponential growth because you're getting free money on free money. So you're increasing your investment every time you compound because all that interest that you earned goes back and is added to the principal and you're reinvesting that whole amount. It's really great for investments because it grows really quickly and you get more and more money, but it's not helpful if you're borrowing money because if you are the one who's paying the interest, then you end up paying interest on interest, which does not necessarily feel so good. So that's what we need to remember as we're moving into today's lesson. So let's activate our learning and learn some new concepts. So with compound interest, we have this compounding frequency. So how often we take our interest that we've earned and reinvest it back with the principal. So how often do we compound it is what we would say. So let's use an example to see how this works. What happens when $1,000 is invested for 7 years at 5% simple interest? So first, we're just going to compare it back to simple interest to make sure that we can see how these two patterns work. So using a chart with year, principal, the interest amount, and the interest dollars and the amount dollars, so the final amount, we're going to look at year 1. So our principal is 1,000. Which means that if we're doing it for 5%, then 5% of $1,000 is $50. So our total amount that we have now is $1,050. In year 2, we still have a principal of $1,000. We still make an interest amount of $50. So we add it to the $1,050 we had before, and now we have $1,100. And this continues every year. If we do it for our full 7 years, we're always investing that $1,000. Adding $50 every year, and this continues increasing by $50 until the end of the 7th year, which means that we have $1,350 in total. So we earned $350 in interest. Okay, so then what happens if we invest the same amount, $1,000, for 7 years at 5%, so that's all the same, but we're going to instead compound our interest yearly. So what does that look like? Again, let's look at this chart and compare. So our year one is exactly the same. We still invest that $1,000. We have 5% of an interest, so we get 50 new dollars. Add them together, we have $1,050. Now this is where it changes. In year two, now we are investing that $1,050, which means then when we take 5% of that, we earn $52.50, which means by the end of year two, we have $1,102.50. So that doesn't seem too exciting. We've earned $2.50 more than in the simple interest, okay. But in year three, now we're reinvesting that $1,102.50, and that just increases. So it means that every time our interest is earning a little bit more, and we're adding it back to our final amount, which means that then we are investing that whole amount. So then by the end of the 7 years, we have $1,407.10, which means that with the compounding interest situation, we earned $407.10. So when we're comparing just the simple interest to the compound interest, we earned a total of $57.10 more just because of compound interest. We didn't do anything differently except that we talked to the bank or whoever we're investing with and said, we want to do the plan that has compounding interest, which means that they compound it more. We don't have to do anything else as an investor. They compound it more frequently. They recalculate that, take that interest into account, and then we make more money. So compound interest grows really, really fast. Here we're looking at this chart or this graph. We can see that this blue line here is the principal, $1,000 that we invested. The simple interest is the red part, so it's increasing at a constant rate. It's that linear growth, and we go up to $3,000. We earn $2,000 after 20 years. But then this compound interest at the beginning, this is green section. So at the beginning, you can see it's very, very little, not very much change. So doing it for a short period of time doesn't really make it much of a difference. But then after 20 years, now we're at over $7,000. So we've earned over $6,000 by compounding, which is 3 times the amount of the $2,000 that we would have earned with simple interest. So that has a huge difference in the long run. This is because compound interest is exponential growth. So then, of course, I want to ask the question, well, can we get more free money? If we have free money, can we get more free money? We know that compound interest earns more than simple interest, but the more frequently we compound, the faster the interest adds up. So the more frequently we take everything that we've earned, the principal and the interest, and we reinvest it, then we end up earning more interest because we've grown what we're earning interest on. Again, this is something that you don't have to actually do. This is something that the bank does or the investment company does. It's not something that you as the investor have to actively do. So let's look at a graph. These lines are kind of light, so I apologize for that. But we can see that here, this red line is if we compound yearly. And we can see that it still has exponential growth. So if we compound once a year, we reinvest the amount of interest that we earned once a year, then we're still going to grow at faster than if we just do a simple interest. But then if we do it by months and we increase it by months, we can see that this blue line increases even faster than the red line. Then if we do it every week, we do it on a weekly basis, then this green line, which is very light, you can see it increases even faster. And then if we do it daily, then that happens even faster. Can't think of a situation where often it is done daily, but your credit cards your interest is calculated daily. So that has an impact when you're paying that loan back. So that's just something to be paying attention to, is that the frequency that happens. Okay, so compounding frequency is laid out on page 29 of your IL booklet. So the compounding period means the time frame in which compound interest is calculated. So it's less than 1 year. I don't think of a situation where you would never want to do it more than 1 year if you're investing. So I don't know when that does happen. But so let's look at the compound frequency language and what that turns into in terms of a number. So if it's annually, this is 1 time per year. If it's semi-annually, this is 2 times per year. If it's quarterly, we are 4 times a year. If it's monthly, it is 12 times a year. If it's semi-monthly, it's 24 times a year. If it's weekly, it's 52 times a year. If it's bi-weekly, it's 26 times a year, because this bi-weekly means every 2 weeks, whereas semi-monthly means twice a month. And if it's daily, it's 365 days a year. So this is a really important chart to remember because it helps you know the numbers that you're going to need to use based on the language that's going to be in your situation. So let's look at the compound interest formula. Now, if you have an old booklet, on page 29, there is a formula that is A equals P times 1 plus I to the exponent N. This is an outdated formula, though the information is the same and the math is the same. We've updated the formula to make it a little bit less complex. It looks more complex, but you don't have to be as intuitive. So with this formula, you need to know you need to do some math before you just put in the letters. Whereas we're going to look at another formula that if you have an updated booklet everything's a little bit more laid out. So A is your final amount, how much money you have in total at the end, including your principal. B is the principal invested, so how much money you start with. So, or if you're borrowing, how much money you borrow. I is your interest rate as a decimal per compounding period. So to calculate this, you have to have your interest rate as a decimal, and then you divide it by the number of compounding periods in 1 year. N is the total number of compounding periods. So to find that, you do the total number of compounding periods per year, and then you times it by the number of years. So if you have a newer booklet, then I've updated it to this formula, which is A equals P times 1 plus R over N, all to the exponent NT. So let's look what these variables mean. So A is the final amount, and P is the principal invested or borrowed. It's the same. Those letters don't change. R is your interest rate, which is expressed as a decimal. So this is just like in simple interest, R is your interest rate. N is the number of compounding periods per year. So this one's different because we now have compounding periods. So this is how often we compound. So it's based on those words. If it's monthly, quarterly, biweekly, those words tell us what that number is going to be. And T is your time in years, which is the same as we've experienced before. T is your time in years. So let's just compare these two formulas so you can see how they are actually the same. So A is your final amount. That's what we're calculating. That's the same. P is your principal, the amount invested or borrowed. Again, that is the same. We're not doing anything different there. But R is your interest rate expressed as a decimal divided by N, which is the number of compounding periods per year. Whereas I is equal to your interest rate as a decimal divided by the number of compounding periods in a year. So as you can see, these are the same things, but it's just that you have to do the math before you put it into the formula, whereas with the newer formula, you do R and N separately, and then you can do the calculation to just make your life easier. Same with the exponent. So N is the number of compounding periods per year, and T is the time, and T, you're multiplying them together. Whereas N in the second formula, or the old formula, is equal to the number of compounding periods per year times the number of years. So again, this is exactly the same thing. It's just that we've written it out explicitly in the new formula, whereas in the old formula, you needed to figure it out on your own. So then the last thing is to figure out how much interest you make. So we're just going to look, the formulas are the same, right? Doesn't matter because we find the amount, the formulas that we have in this lesson, we're finding the amount. But if we want to find the interest, that's the total amount, right? How much we have altogether. So that means that it has both the principal and the interest added together to find the total amount. Even though we don't do that calculation in this formula, that is what's happening in the background. So that means to find the interest, we need to do our amount, our A that we find in this formula or from this calculation, and we subtract the principal from it in order to figure out how much this interest that we've just made. Just to remember. Okay, so before we put all the pieces together, we are going to make sure that we understand how to figure out each of these parts. So on page 30, we have some questions about understanding the principal. So the principal, remember, is how much money you invest or borrow. So let's look at example 1. Parker has $10,000 in a savings account at CIBC, earning 2.5% interest per year, compounded monthly. If he leaves his money in this account for 5 years, how much money will be in the account at the end of 5 years? So that's a lot of information. Right now, the only thing that we are interested in, the only thing that we are interested in is the principal. That's all we're trying to figure out. So P is equal to, how much did Parker invest? Well, $10,000. So P is equal to $10,000. That is all I'm asking for in this question, to just make sure we can find that information. Example 2, Ashley borrows $25,000 at a rate of 8% per compound, 8% per year compounded quarterly. If she doesn't pay the loan back after 15 years, how much money will she owe at the end of the term? Again, we are just looking for the principal. So the principal is equal to $25,000. That's how much she borrowed. And that's all that we're looking for right now. So on page 30, question number 1, the support question, this is practicing just finding the principal. It's really important, like we talked about. These questions have a lot of numbers, a lot of information. So figuring out which number and which information is applicable to which variable is super important. That's your first step to make sure you can do that. Okay, so now we're going to understand rate. So it has 2 parts. It has the interest rate is has the actual interest rate given to you by the bank, which is your R, and then it has the number of compound periods in 1 year. So we need to find 2 things in order to know what our interest rate is going to be, the calculation we're going to need to have. So interest rate is the percentage of the principal that the bank is giving you for investments or that's charging you for loans. The compound periods or frequency are how often the interest is added up to the principal. Okay, so if we're going to do an example, Parker, again, we're using the same example, but now we're looking for different information. We know the principal is $10,000. So now we're looking for the interest rate. So we're looking for R and N. So Parker has $10,000 in a savings account at CIBC, earning 2.5% interest per year, compounded monthly. So that's where our information is. And the rest, if he leaves his money in this account for 5 years, how much money will be in the account at the end of the 5 years? That's not important for this for right now when we're looking at interest. So our R is 2.5%, which remember we need to transfer and translate just into a decimal. So 0.025 is 2.5%. We don't want it in percentage anymore. And then N is compounded monthly. So what does monthly mean? Monthly means 12 because there are 12 months in a year. That's what that list of all the different compounding frequencies is super important, so you know. And that's all we need to do for this question. We're just looking, we're not even calculating it. We're just pulling out that information so that we can find it. Example 2, Ashley borrows $25,000 at a rate of 8% per year, compounded quarterly. If she doesn't pay the loan back for 15 years, how much money will she owe at the end of this term? Again, we are looking for the R and the N. So the R is 8%, which is equal to 0.08, and the compounded quarterly. So that means that we're compounding every 4 times a year, every 3 months. So 4 is what our N is equal to. For these questions, if writing on the question and underlining things or boxing things or using highlighter, if that helps you, go for it. Totally do that. Figure out how to find the information that you need and where it makes sense. So now on page 31, question 2 makes you practice pulling that information out of the question. Understanding time. This is on page 32 of your owl booklet. So again, this has 2 parts. It has a total number of time in years, and the number, so that's T, and N is equal to the number of compounding periods in 1 year. Is this N the same as the N when we were finding the interest rate? Yes, that is why they are the same variable, because the compounding is the same for the whole situation. So the N is the same thing that we found before. So this represents the total number of times the investment or loan is compounded in total. I say total twice because it's important. And T must be in years, so you may need to convert it if it's based in months, weeks, or days, just like we have to do simple interest. So Parker has $10,000 in a savings account at CIBC, earning 2.5% interest per year, compounded monthly. If he leaves his money in the account for 5 years, how much money will be in the account at the end of 5 years? So again, here, our T is 5 years, and our N is compounded monthly, so 12. It doesn't matter when you're listing your variables, it doesn't matter which order you do them in, as long as your variable and the number are correctly connected. But I don't care if you do principal first or principal last, it doesn't matter. I do what makes logically sense for me in that moment. Example 2, Ashley borrows $2,500 at a rate of 8% per year, compounded quarterly. If she doesn't pay the loan back for 15 years, how much money will she owe at the end of the term? So again, their time for this question is 15. And our N, how often it's compounded? Well, it's compounded quarterly. So again, it is 4. So on page 33, question number 3 will help you practice finding that time information. All right, so that is finding the information, but now we need to put it all together and actually do the calculations. So how do we do that? On page 33 in your booklet is where this starts to happen. So let's do it with an example. We have our formula. How do we apply it? An amount of $4,000 is deposited into a savings account at a rate of 7% compounded monthly. Calculate the total balance after 5 years. So what I like to do, what works best for me, is to list out my variables and figure out what I know and what I don't know so that I can figure out what it is that I'm finding. So this question says calculate the total balance after 5 years. So that means that I know I'm trying to find A. The principal is $4,000. The rate is 7%. So R is equal to 7%, which equals 0.07. N is 12 because it's compounded monthly. And T is 5 because it's 5 years. So then I have all of my variables I figured out and organized. Again, you don't have to do it in the order that I've done it in. You do what makes logical sense for you. You don't have to color coordinate or highlight it like I have. You do what makes sense for you. If this is helpful, great. If it's not, don't do it. Then I like to write out my formula so that if I've made a mistake in copying out my formula, that is easier for me as the teacher to figure that out what the problem is, opposed to if you are just completely misunderstanding it. Then I fill in all of the variables that we know. So A equals 4,000 times 1 plus 0.07 divided by 12, all to the exponent 12 times 5. This is really, really important to remember the order of operations, to remember your BEDMAs. If you're just putting this all into a calculator, making sure you put the brackets in the right places and that everything is happening the way they're expecting is really important. If you're going to do the steps individually by hand, you need to make sure that you are doing them properly in terms of BEDMAs, the order of operations. If you need a refresher on that, let me know and I can send you some supports. So if you're going to do it in some steps, so then you have A equals 4,000 times 1.00583 to the exponent 60. So a note to make is that if you do this when you have a really long decimal, generally if it's more than 5 decimal places, I would keep it in your calculator to get the most accurate information. So I would keep that division, the 0.07 divided by 12, I would keep that and use that opposed to rounding it off and writing it down. If that doesn't work for you, and you need to round it off, that is okay. It just means that you will be slightly off. I will not take marks off if I can just tell that it's just a rounding error. But over time, this will make a bigger and bigger effect the more times you do these sorts of calculations on after each other. So it's important to try to be as accurate as possible. So then in total, this is $5,670.50. So the total balance in the savings account after 5 years is $5,670.50. Remember, this includes the principal, how much was initially invested. So that's not all interest. That includes the investment, the initial investment. So as I said before, compounding is great for investments, but also apply to loans and debts. So something to remember, because it is not always awesome if you have to pay interest on interest. That's not good. So let's look at a credit card situation, a borrowing situation. Xavier's credit card balance is $800 at the beginning of July with an interest rate of 19.99% compounded daily. He forgot to pay his bill until the next month. How much interest did he have to pay? So we're assuming that he doesn't make any more purchases. He doesn't make any payments. This is just using the 800 of the interest rate. So looking at the question, it says, how much interest did he have to pay? So we're looking for the interest. So remember, we calculate the amount, but to find the interest, we need to do our principal plus interest to figure that out. So then our principal is $800. Our rate is 19.99%, which is equal to 0.1999. N is 365 days. This is compounded daily. T is 31 divided by 365. Because this is for the month of July, there's 31 days in July, but that's 31 days out of 365 days. So that's why we have to do that, because it needs to be per year, right? So then we use our formula and we fill in the variables that are the information that we know. So A equals 800 times 1 plus 0.19999 divided by 365 equals, to the exponent, 365 times 31 divided by 365. So if you're going to round it off and do the steps in between, that's 800 times 1.00054 to the exponent 31, which is equal to $813.69. Great. Well, are we done the question? Let's go back. No, it says how much interest did he have to pay? So we still need to calculate the interest. So A is equal to principal plus interest. So that means that interest is equal to the amount, take away the principal. So $813.69 take away 800 is equal to $13.69. Sorry, there is a typo here. So Xavier has to pay $13.69 in interest for the credit card balance he carried in July. Now you can do the support question on page 35, question number 4, where we put all the pieces together. Let's do a couple more examples while we can. Chris wanted to invest $1,000 at 4.5% compounded quarterly. How much bigger will their investment be after 20 years opposed to after 10 years? So here we're comparing two different situations, which is often how these questions work, is that you're comparing, you're deciding what is best for you. So what do we expect? We expect that 20 years is going to be much bigger. So we need to do for 20 years and we need to do it for 10 years. And then we need to find the difference, how much more we earn in 20 years. So we have our principal, which is $1,000, our rate, which is 4.25%, which is equal to 0.0425. The N is a compounding period, which is 4 because it's quarterly, and T in this case is 20. So put into our formula, P equals, sorry, I wrote that wrong. This is why writing down your formula is important, because then when you randomly write it down wrong, you can maybe catch yourself. Okay, A is equal to P times 1 plus R over N to the exponent NT, which is equal to 1,000 times 1 plus 0.0425 divided by 4, all to the exponent 4 times 20. And I'm going to use my Desmos calculator because it is my friend. So 1,000 times, open a bracket, 1 plus 0.0425 divided by 4. Remember, I want to get it outside of my last bracket, so then I put that and then to the exponent, and I want my 20 times 4 to be all together, so I put that in brackets as well. So I get $2,329.18, 23.29.18. Okay, so what if we only did it for 10 years? So our principal is still the same. Our rate is still the same. Our compounding is still 4, still the same, and our time now is 10. So in this case, you might not have to write out your formula again. You can if that feels good for you. But if you're running out of space or you just don't want to, you don't have to. I'm not going to take any marks off, but if you make mistakes, it's going to be harder for me to figure out why you did. To the exponent 4 times 10. So again, I'm going to use my Desmos because I've only changed one number. I can just go back in and change that 20 to 10, and I get $1,526.17. So 1526. So do we answer the question? Well, the question says, how much bigger will the investment be after 20 years? So no. So the difference, which tells us how much bigger one is over the other, is $2,329.18. Take away $1,526.18. I think that 18 cents is wrong. I think I wrote it down wrong, but it's no big deal. It's a penny, so it's supposed to be 17 cents. But we'll probably survive that. I did it wrong. I rounded wrong. See, rounding happens. And I forgot decimal place. $1,526 and 18 cents. Desmos doesn't always cause me so much trouble. Why? Just today. Oh, because I'm pressing the wrong button. This means move. This means delete. There we go. $803. Sorry about that. So by investing for another extra 10 years to go from 10 to 20 years, you make another extra $803. So something to consider. All right, let's consolidate what we've learned today. So this was lesson 9, and this is focusing on compound interest. So compound interest grows exponentially. The pattern increases or decreases at a constant ratio. So the same amount we're multiplying or dividing by each time. Our formula is A equals P times 1 plus R divided by N, all to the exponent NT. A is your final amount. P is your principal. R is your interest rate. T is your time in years, and N is the number of compounding periods. Also remember that to find your interest, you need to do your amount, take away your principal to find out what your interest was. So hopefully you can explain how compound interest earns more for investments, but also costs more for loans. And you can identify the principal, interest rate, compounding periods, and time in order to find the final amount. And that is our lesson for today. So if you have any questions, please reach out and connect with me. Call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. Send me an email to bronwyn.slate, and that's spelled BRONWYN.SLATE at nnec.on.ca. Connect with me through Facebook at bslatewasa or YouTube at also at bslatewasa. Remember, all of our lessons can be found under a playlist called MEL3E. Everything is there, both from this year and a previous year, so that you can look ahead or listen to the same thing and see if I've explained it in a different way that makes more sense to you. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 to 11, so that is not a good time to get a hold of me. If you send me an email and ask me a question, I will most likely get back to you within 24 hours or so, 48 hours, generally the latest if something has come up. So we can always arrange a time to connect if you need direct connection and our schedules don't line up. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.